Okay, guys, today our topic is weight force, which is more commonly known as gravity. Remember, maybe you were told this story, maybe you weren't, but supposedly Isaac Newton one day was sitting under a tree and an apple fell on his head. And he thought to himself, well, why did this apple fall on my head? Right? And then he started thinking about, like, why does anything fall? And what causes the moon to revolve around the earth? And why does the earth revolve around the sun? What keeps everything all together? And the answer is the force of gravity. It's an amazing force, and it works all the time. It's really what keeps our solar system together, what keeps the universe together, right? This attraction between bodies or objects, okay? Gravity is an attractive force, meaning it always pulls toward itself or towards each other rather than pushing them away from each other. So you can think of, right, sometimes magnets, right, they push away from each other. That's not gravity, okay? Gravity always draws two objects closer together. Gravity is also what's known as an at-a-distance force. That means that the apple does not have to touch the earth in order for the force to exist or the force to be applied, right? It's not an applied force. Notice, right? I have to push a desk, a cabinet, another person if I want them to feel my force. But gravity is working all the time. I don't have to be touching anything in order to be gravitationally attracted to them. So everything that has mass, right, has a gravitational field. The sun, the earth, an apple, you, electrons, right? Everything is attracted to each other, right? The person next to you, the person across the street from you, the person, right, upstairs. Everything is attracted to each other, at least gravitationally. On Earth, we know, this is an important number, we know that gravity is 9.8 meters per second squared. Notice, this is called the acceleration due to gravity, okay? That is constant for Earth, okay? The acceleration due to gravity is constant for Earth. Notice the units are meters per second squared. Those are our acceleration units. Now, the force of gravity acting on an object. So look. This is different, right? The force of gravity is different than the acceleration due to gravity. The force of gravity is known as weight, okay? Remember, weight is different from mass because mass is measured in grams. You know that from chemistry. While weight is a force that's measured in newtons in physics, right? Lots of times, though, we measure it in pounds, right? Colloquially, we say, hey, how many pounds are you? Or how many pounds did you lift? Or, right, how many pounds of apples do you have? That is a measure of weight. If you travel to a different planet, let's talk about the moon. The moon has a different acceleration due to gravity, okay? Your mass is the same, but your weight changes, right? The force on that mass changes because the moon is smaller. Okay, that's why they do these bounding leaps, right? Instead of walking normally. All right,